In this video, we'll look at how different operations on a function will affect its graph and how that manipulation affects the picture you would draw to sketch out the graph of a function. Let's start by assuming we have the graph of f, whatever it might be, and I want to know how these different functions will look like if we tried to graph them based on how they will change that graph. So first we have f of x plus 3. So this plus 3 says after you're done with finding what f of x is, move it up by 3 units. So this is a vertical shift upward by 3 units. The f of x minus 2 one, for the second one, is going to do a horizontal shift. And the idea is basically the following. If I look at this function and call it g of x, if I want to find g of 3, I then go to f and I say, let's plug in 3 for x. So what's really saying is for g of 3, I want to evaluate f of 1. So I want to take the graph of f, and the value at 1 should become the value at 3. So I want to take the graph of f and drag it to the right by 2 units. This is a horizontal shift right by 2 units. Next, for 2 times f of x, this means I want to take the value I would get from f and I want to double it. So I'm effectively stretching this graph vertically. This is a vertical stretch by a factor of 2. For negative f of x, that means takes the value and sort of flip it to the other side of the x-axis. This is a reflection of the graph of f over the x-axis. Next, we have f of 2x. So that basically says if I want to find the value of this function, at 1, I look at f of 2. If I want to find the value at 2, I look at f of 4. I'm effectively squishing the graph in towards the center, so I hit every value sort of more rapidly as I move out in x. So this is a horizontal compression by a factor of 2. F of minus x is going to take whatever value, and when I want to find the value at a certain point, I look at the value of f on the other side of the y-axis. So this is a reflection across the y-axis. And then we can combine a lot of these together for number 7 here. So this, I'm going to work inside out. So I want to do these things in order. The first thing is the horizontal shift. That's the furthest in the parentheses. So horizontal shift right by 1. Then I'm going to flip over the y-axis. That's this minus sign in front here. I want to stretch by a factor of 3. That's the 3. And then I want to shift up by 2. That's the last thing at the end after the multiplication part. So you have these simple examples of what each individual operation does, and you can combine it with something more complicated. In general, sort of the most complicated thing you could see with this is something like the function g of x being a f of bx minus c plus d, where now each letter here is a constant, is a number that has a certain effect on this graph. So a here is the vertical stretch factor, like we saw previously. B is the horizontal compression factor. C is the horizontal shift. And then D is the vertical shift. And notice the minus sign here. The way these are set up, the horizontal shift is to the right, and the vertical shift is up. So if I have, say, f of 2x plus 1, that is then a shift of 1 to the left because it's minus negative 1. This is how you can break down how all these different terms come together to affect the graph of a function that you're trying to modify.